Assalamualaikum. My name is Muhammad Zafri Haris bin Muhammad Rustam. My metric number DE2030024. First of all, introduction. Eddy current brake, also known as magnetic brakes, use magnetism and motion to safely slow down or stop moving objects like car or machine. They work using electromagnetic induction. When a metal object moves through a magnetic field, it creates eddy current in the metal. This current produces their own magnetic field that push against the original wire, creating a force that flows the object without any physical contact. Unlike regular brakes that use brake pad or disc, magnetic brakes don't wear out easily. This makes them last longer and require less maintenance. They also provide smooth and steady brake without sudden stop. Our project will show how this system works and how it can be used effectively.
Assalamualaikum, my name is Muhammad Azim Sharif. Metric number DE2030031. So I'm going to present about problem statement. Right, so conventional brake wear out easily because they are rely on friction, so they need to regular maintenance and part replacement. That's why we need a low maintenance alternative because a braking system doesn't require direct contact, allowing for smoother and quieter operation. Our project aims to design and test an eddy current brake prototype. This will help us understand how electromagnetic induction can produce a braking force and also see how different variables like magnet strength and material conductivity affect its performance.
Objective and scope of work: to comprehend how lens law produce eddy current and how they result in non-contact braking. Second, to use a basic part like a metal grinder disc, a N52 neodymium magnet, and a toy crane to design and construct a functional prototype. The third one is to evaluate the effect of this speed, magnet strength, and this to magnet distance on braking performance. On scope of work, this project used a toy crane to support a neodymium magnet and a motor-powered rotating grinder disc to create a small-scale eddy current braking system. The disc slows down when the magnet is close by and starts spinning again when it is farther away. As the experiment shows, testing entails varying the magnet distance and noting how well the disc is slowed, similar to the system found in the trains and elevators. The setup demonstrates the advantage of contactless braking, including decreased wear, zero friction, and silence operation. Methodology: experiment purpose: to demonstrate the eddy current magnetic braking using a simplified DIY material. Second, to observe how a magnet distance from a rotating disc affect braking through non-contact force, that is Lenz's law. Number 2, the component use. The component that was used in this experiment was toy cranes to adjust the magnet distance from the disc. Number 2, N52 neodymium magnet to provide a strong magnetic field. Number 3, grinder steel disc to rotate and drag to magnetic braking. Number 4, DIY electric fan motor to spin the disc using two pieces AA batteries. Switch to turn the motor on or off. Finally, wood or plastic base to hold everything securely. In this discussion, the fan motor spins the steel disc when powered on. The toy crane lowers the neodymium magnet close to the disc without touching. As the magnet moves closer, eddy currents form in the disc, causing it to slow down and eventually stop. When the magnet is moved away, the disc starts spinning again, and finally this process was repeated multiple times to confirm that magnet distance affect braking strength. This is some video or some clips during our project simulation. This is some video or some clips during our project simulation. This is some video or some clips during our project simulation. This is some video or some clips during our project simulation. This is some video or some clips during our project simulation. This is some video or some clips during our project simulation. This is some video or some clips during our project.
Good evening. My name is McAllister Delana Smith. My net metric number is DE230015, and I will present about the conclusion. So the ID current magnetic braking project successfully demonstrates the concept of non-contact braking using electromagnetic induction. Through our prototype, we observe how the motion of a conductive metal disc can be slowed down without physical contact by generating opposing magnetic field through eddy currents. This system proved to be effective, quiet, and low maintenance compared to traditional braking system. By analyzing the effect of magnet distance, this material, and magnetic strength, we gain a deeper understanding of how real-world applications such as train brake or elevator system utilize this efficient braking method. Overall, the project has achieved its objective and highlight the practical potential of electromagnetic principle in modern engineering.